Hi, this is Tim Urdan, author of Statistics in Plain English, and in this video what we're going to do is calculate a standard deviation. So, suppose that I've got a sample of 4 college students, and I want to know how much coffee they drink, how many cups of coffee they drink. So I asked them how many cups of coffee they had yesterday, and the first person in my sample said they had 3 cups of coffee. Second person said 0. Third person said 5. Fourth person said 4. This could be coffee or other caffeinated drinks. To calculate a standard deviation, the first thing that we need to do is calculate the mean for the sample. This works with whether it's a sample or a population, so we'll do both. We'll treat it as both. But let's start by treating this as a sample. To calculate the mean, first you have to add up all of the individual scores. 3 plus 5 is 8, 8 plus 4 is 12, and then we have to divide that by the number of scores. "12 divided by 4, there's 4 scores, equals 3. So the mean for this sample is 3. To calculate a standard deviation, you first have to calculate a deviation between each individual score in the sample or the distribution. Deviation between the score and the sample or population mean. Square that. So we'll do that now. 3 minus 3 squared equals 0. 0 minus 3 squared equals 9. 5 minus 3 squared equals 4. 4 minus 3 squared equals 1. That is my collection of squared deviations. And now I need to find the sum of the squared deviations, so I add those all up. Zero plus 9 plus 4 is 13, plus 1 is 14. And that is the sum of the squared deviations. The next step is to divide that by n if you are doing this if you're doing the standard deviation for a population, or n minus 1 if you are calculating the standard deviation estimate for a sample. We are going to treat this as a sample, so we're going to divide that by the number of cases minus 1. So we have 14 divided by 3. 3 goes into 14. Four and 2/3 times, so 4.67. And that is our sample variance. Sample variance is 4.67. Then the last step is to find the standard deviation by taking the square root of that. So the square root of 4.67 is about 2.16. And that is the standard deviation of the sample. The standard deviation of a sample is actually the estimate of the standard deviation of a population using the sample data. But we'll just call it the standard deviation of the sample. Let's take a look at the formula for the standard deviation so we can see how these calculations fit with the formula. So this is the symbol for the standard deviation of a sample. The standard deviation equals the square root of the sum of the squared deviations. These are all the squared deviations, and this is the sum of the squared deviations. divided by n minus 1. The sum of the square deviations divided by n minus 1. N is 4, n minus 1 is 3. 14 divided by 3 is 4.67. Then we take the square root of that whole thing. The square root of 4.67 is 2.16, and that's how we got the standard deviation of the sample. Now, what if this had been a population? We're going to go through and adjust this. The formula would change a little bit. That is the symbol for the standard deviation for the population. And instead of doing n minus 1, we're going to use n, which is the total number of cases in the population. So if we treat this as a population, you'll notice that none of this part changes. The mean would still be the same. The formula, the symbol for the mean would look different. So the symbol is now mu, but the actual mean itself stays the same. The mean will still be 3. The square deviations will all be the same. The sum of the square deviations will all be the same. And this is where we change it. Instead of dividing by n minus 1, we divide by n. N here is 4. Um, 14 divided by 4 is 3.5. So 3.5 is our variance, our population variance, which has that symbol. Last step is to convert that variance into a standard deviation by finding the square root. So the square root of 3.5 is 1.87. And that is the standard deviation if we were treating these data as population data. So you can see it's a bit smaller than the standard deviation was when we were treating this as sample data. That's because dividing the sum of squares by 4 will give you a smaller number than if you divide it by 3. When the sample sizes are larger, say you have a sample size of 100, the difference between dividing by 100 and dividing by 99 is not going to produce a very big difference. But when your sample sizes are tiny like this, the difference between dividing by 4 and dividing by 3 can be pretty large and lead to pretty big differences between the standard deviations of the sample versus the population. So that is how you calculate a standard deviation. A little bit tedious, but not too difficult, and I hope that's helpful.